So this journey really started about a year ago, where at my work we started considering whether or not we should move to React and Flux. Previously, we were using Backbone with D3, um, and it was causing us some troubles. So we started thinking about other architectures that we could use, and React and Flux started to become one of our best options. So a little bit of a backtrack. I work at a security company called Illumio, and the best analogy I've heard so far of what we do is what I like to call the hotel analogy. So if you think of a traditional data center as a hotel, and all of the servers that you want to secure to be the hotel rooms, then traditionally with firewalls, we're just securing only the front door. So as soon as an intruder gets into the front door, they have free access to all of the hotel rooms. What we try to do is secure the hotel rooms themselves. And with Illumination, what we do is show you visually who's going in and out of each hotel room that you care about and how you can visually secure those rooms and say, I only want to allow this traffic in, and I don't want this traffic in. So what it looks like is these squares represent our servers, what we call workloads, and they are grouped into this construct of what applications are running on these workloads, in which environment, dev, prod, testing, and what locations. It could be like physical locations, it could be kind of virtual locations, so that we can identify the rules that we want to write by these groups. So you can see these are workloads when you first pair them, when you first install our software on your servers. And then we want to tell each of these workloads what their role is, what their function is. So for example, for this particular one I clicked on, it's a database. So I say, okay, database. And for this one, it is, oh wait, no, that was a load balancer. Okay, I'll go back. So this one is a database, and I know because it says database in there. And this is all going across the internet. So depending on the internet speed, this might be lagging a lot. Ooh. Oh yeah. So I originally wanted to show you guys Illumination and demo some of the functionality, but unfortunately Illumination is highly dependent on network speed. And as you can see, after I clicked on save, it's still kind of loading. So I may or may not be able to show you everything I wanted to. In that case, we're going to go back to my backup plan of these GIFs. So, oh, it went. Did you guys see? So, it went to right here. Okay, I'm going to try something else. So now that we have the roles assigned to these workloads, what we can do is write rules on them. So we say, between this web workload and this processing workload, I want to add a rule for this service. So I say save, and depending on how nice the network wants to be to me, it will turn green. Oh, there we go. Yay! But I'll show you these GIFs. So this is me turning the roles, or assigning the workloads to the roles. And it turns. And then this is how we can secure the entire group. So just assigning rules to each of these lines that are the traffic links, that represent the traffic links. So the reason why we started thinking about a potential alternative to Backbone with D3 is because it presented us with two primary challenges. The first being that if you take a look at these elements, these workloads, and these groups, there's actually a lot of visual complexity in them. So depending on the data state of each of these elements, I can have borders, I can have not borders, like there could be dash borders, and they all encode a certain meaning. And on top of that, some visual elements, such as the groups, their state is actually highly dependent on the workloads, on the state of the workloads within them. So a data change on a workload could potentially change what the group itself looks like. So what that meant for us is that the first problem we used to be solving with D3's what we call enter update exit pattern, and we wanted to keep track of like all of the DOM elements that was going in, all of the DOM elements that we were removing, and it became such a jumble in our head to keep track of that we got a lot of bugs. And the second thing about all of these views depending on other views meant that in Backbone, we were listening to views were listening to models, and models were being mutated by views, and it was creating this giant spaghetti ball of events. So for this talk, because I can't show you the code of Illumination, I went and created an example expense app that was initially supposed to be very simple, and then it got really out of hand because I had a lot of fun with it. And it has three primary functions. First, you can add an expense. So let's say this morning I wish I would have gotten a coffee. And then that adds it right here. And then I could say that I put it on my Chase credit card, and that's a category. And to categorize each expense, I drag it over the category I want, and then categorizes it. So I'll put this under groceries. And I could click on an element to inspect its details. And I can click on a category to inspect it. And I can also click on an expense to potentially edit it. So these are kind of like the simpler functionalities. It's kind of like a simpler version of a lot of the functionalities we have in Illumination. So when I first heard about React about 2 years ago when it first came out, I didn't pay much attention to it because at its core, it sounded a lot like what D3 was already doing. So React is a library that Facebook came out with to help us solve the problem of a single page app and all of the data changes that can change different parts of that application. With D3 is a library for developing interactive data visualizations, and it also, I see a hand, hi. Oh, yes. Let me do that. Thank you for letting me know. And D3 is a library for making data visualizations that actually also tries to figure out how to intelligently update different parts of the visualization based on data change. So they do a lot of the same things, but with different approaches. So I have, for my example, the DOM structure of one of these expense rectangles. So it has two rectangles and one text element. And the code to actually render this in React is I just tell it my structure that I want in the render function. And React will then take that, and their virtual DOM will keep track of the elements and then calculate the minimum set of changes to the DOM to go from one state to another. So we don't actually have to do much work to figure out how to update between states. With D3, the approach is called enter update exit, or enter exit. and it exposes to us a function called enter, and that tells us of the subset of the elements we need to insert into the DOM because of the data change, and also the subset of elements that we need to remove from the DOM because of the data changes. So with D3, instead of React taking care of it all for us, we have the ability to control what we do, but it also means that we have to be the ones doing the thinking and the keeping track of. So because they're so similar and they try to do the same things, there's this problem of who does what, who keeps control of the DOM, and how do we make sure that, in particular, React doesn't get angry, because when we tell React all of the elements we wanted to keep track of, the virtual DOM, if we then go and change attributes not through React, it freaks out that we kind of like pulled the rug from under them, and it actually gives us really nasty bugs that like take half a day to find because we have no idea what's. This is from personal experience. So the pattern that we came up with for illumination was that React manages the structure. React manages what gets entered into the DOM and what gets exited from the DOM, and D3 manages the attributes. And the primary reason for this thinking is it takes advantage of two things. First of all, that React is very good at making things I can't ever say this word, componentized, and thus easier to reuse. And it also abstracts away the structure from us so that we don't have to keep track of it. And with D3, it has some really amazingly beautiful functionality, one of them being the transitions. So animating DOM elements that we can take advantage of. But transitions require D3 to have access to at least the attributes of an element. So for example, this is transitioning in the expenses in the expense app, and at the end of the transition, this is what the DOM structure of the expense looks like. So previously, we saw just kind of React takes care of this first part, saying this is the SVG element I want and the class name, and then D3 takes care of the rest over here. And how we did that was, on the left-hand side, we have the D3 code, and on the right-hand side, we have the React code. So we grouped the D3 code into two parts, first being the enter function, and the second being the update function. And then you can see with both of them that they're only changing the attributes of the selection of DOM elements that we've given it. And in update, we call transition on them and have D3 calculate the states between the enter and update. And from the React side, we call the enter function from component mount. So right here. So this means that when React has inserted the DOM element into the DOM, we set all of the attributes, the starting attributes, and when React has finished calculating the diff and finished updating it to its next state, then we update it with the next set of attributes with D3, and that's also when we ask D3 to calculate all of the in-between attributes between when it first started and when it ended. So when we first read about Flux, it kind of clicked right away because we were having so much trouble with the events going back and forth between the views and models, and it was hard to debug because we didn't know where the events were being triggered. With Flux, it has a unidirectional flow, data flow, and so all of the data is stored in the store, and then the store listens to any dispatch event triggered by the dispatcher, and anytime any of the data changes, it emits a change event to the view. The view then takes what's in the stores and renders the next, re-renders itself. Whenever a user interacts with the view, we trigger an action that then goes and calls the dispatcher to let the stores know that something has changed. So the most important part of this is that the views can get the data from the stores, but they're not allowed to mutate it without first having gone through the dispatcher. And the dispatcher's primary job is to make sure that we don't have any race conditions in updating the data. So how this translates for us in this expense app is that the stores I have are for the graph itself. So this right-hand side is the graph, and this left-hand side is the panel. So the stores keep track of the expense data, the category data, anything I might have changed on the graph, and any of the selections. So currently I've selected this Safeway expense, so any of the selections I might have. And the views in the React components, I have the expense app, that's the root parent of all of the view components. And then I have the graph component that renders the right-hand side. And then I have the panel component that renders the left-hand side. And then I have the expense component that I previously showed the code for, and the other three visual elements that are on the graph. And then down here in the visualizations, this is the D3 code that I call from the React components up here. Sorry, what? Oh, yeah. Here, let me. Oh, yeah, that looks a lot better. Yeah, these are the stores. These are the components. And then these lines all represent, so the dotted lines means that I've subscribed to a change listener from the stores. The double stroke means that I not only instantiate, but also pass down data via props. And the single line indicates that I only instantiate and I don't pass down data. So in the stores, this is what the categories look like. It has an ID and it has a name, and that's it. But to be able to render it on this side, we need a lot more information. We need the color, its fill color. We need its size, and we need its X and Y positions. And the same thing with the expenses. We have some basic information, but we need a lot more than that to be able to render it on the screen. So the biggest lesson we learned from having gone through this process with Flux is that these calculations of between what we get from the store and what we need to render on the screen needs to happen at the latest possible moment of the Flux cycle. So in the expense app example, I did it in the graph component. And so you can see the graph component on component mount, subscribe to change listeners in the stores, and then whenever its parent app component changes and passes down new props, we also call this onChange function. And what this onChange function does whenever the data changes is it actually just goes and calculates all of the data we need to render. So it calculates categories and expenses that you saw up above and fills it in with the render data. And it also calculates the data for these links. And it gives some metadata of like which elements are highlighted and how they should be positioned. And then it sets state of all of those new information and triggers React to go through the life cycle again. And when React goes through the component life cycle, we get to render, and we instantiate each of the components, link, category, and expense components, and returns them. So the reason why this was really important for us is because previously when I showed you illumination, I was changing one element at a time. I was changing the role on a workload. I was adding a rule for a traffic line. But the difficulty we had prior is our users could go and change the states of all of those things in all of these other pages, and we wouldn't know the set of changes that they would have made, so that when they go back to the illumination page, we didn't know how to reflect those new changes. But with Flux and React together, what we found was because all of these other pages were mutating the same set of stores that illumination was listening to, that whenever a change was made in a different page, it would update the store, and then the illumination page would know about it and recalculate the data to render on the screen, so that whenever the user came back to this page, it would be the correct set of data that's already been calculated and shown. And that allowed us to do things like being able to, say, take a group and then get it ready to write rules on them. So it allowed us to say, go into a different page and set some of the attributes. And then, so we could bulk edit the workloads, create a new rule set, come back, and have the container ready. Whoa, oh, look at that. And then we can then click on each of these links and add the rules. So moving to React and Flux from Backbone has solved a lot of the problems for us. It also has given us a lot of new things, new opportunities to explore. So because it kind of did away for a lot of the bugs for us, the previous ones that we had, now we can start considering new things that are very interesting to us. So for example, on this screen you see about 50 workloads. A lot of our customers have thousands of workloads or tens of thousands of workloads or hundreds of thousands of workloads. So what we're currently working on is how do we scale that up where we're not overwhelming them and we're not overwhelming the browser, but still giving them the functionalities they had at 50 workloads. I've also gotten some very interesting feedback while preparing for this talk, and somebody asked me, you allow both React and D3 to have control of different parts of the DOM. Why is that? Why not just have React have the full control of the DOM and then have D3 just calculate the data? And I thought a lot about that, and I thought that was really interesting. But I think that currently we're not there yet. I think currently React has a really good set of things that it can do, and D3 has a really good set of things that it can do, and we should be able to leverage both of them. And I think React gives us enough flexibility to be able to do so. So the way that I started thinking about this isn't a one-size-fits-all solution for all problems. I'm hoping that this is a flexible approach that where if we're asked to build new features on top of it, or we are asked to build new features on top of it, maybe sometimes it fits in really well, and sometimes it doesn't. But it's flexible enough for us to tweak parts of it and then be able to incorporate the new things. And another thing I realized while thinking through all of this is about 2 years ago, I joined the D3 data visualization community, and I met a lot of really cool, amazing people that were really, really intelligent, and they talked about all of these principles that were like really cool, and I didn't really understand, and I felt a lot like a poser because, and then going through preparing for this talk, I realized that I think for me, what I want to start working on is a concept of data visualization that's actionable. And I think React and D3 together helps that a lot. So thank you very much. And if you have any questions, I'm here.